The rest of this section is going to look at solving inequalities. So before we start solving inequalities, let's look at sign properties on an interval. Okay, what we're saying here is f is continuous. So some function is continuous over an interval from a to b, and the function is never equal to 0, which means it never crosses the x-axis for all the x's in ab. Then your function has to either be greater than 0 for all the x's in that interval, or it's got to be less than 0 for all the x's in that interval. So let me draw two different things here. So here's my x-axis and my y-axis, and I'm going to draw this twice. So what this is saying is, hey, if you've got some function that's continuous over some interval from a to b, and it's never equal to 0, which means it's never going to cross the x-axis, then the function is either always going to be above the x-axis, or that function will always be below the x-axis. Well, if I'm above the x-axis, the y values here are always positive. And if I'm below the x-axis, the y values here are always negative. Sign changes. So signs, by sign changes here, we're looking at the change from a positive to a negative, or from a negative to a positive. So sign changes of a function, so our function is going to change from being positive to negative or negative to positive at any real number x where the function is either discontinuous or where the function is equal to 0. So partition numbers are places where we can change signs in our functions. And again, those happen in two places, where we're discontinuous or where our function is equal to 0. So what we're going to do is we're going to construct one of these sign charts to solve inequalities. In order to solve a polynomial or a rational inequality using a sign chart, the first thing we want to do is rewrite the inequality so that we have an expression on one side and the inequality symbol and then 0 on the other side. Then we're going to find the partition numbers for the expression, draw the number line and place those partition numbers on there, and then choose a test point from each of the sections that we get once our partition numbers are placed on our number line. We then evaluate each expression at the test point and determine if the inequality statement is true or false, and our solution set is going to be anywhere that we are true. Let's do number 9. Number 9 says use a sign chart to solve the following inequalities. So first, rewrite it so we get expression on one side and 0 on the other side. I don't have 0 here, so I need to subtract 4x from both sides. So I end up with x squared minus 4x minus 5 is greater than or equal to 0. So step 1 is now done because I have expression on one side, 0 on the other side. Step 2, find the partition numbers. What are the partition numbers? The partition numbers happen in two places. The first one is anywhere we are discontinuous. Well, this is a polynomial, x squared minus 4x minus 5, so it's continuous everywhere, so there's nowhere it's discontinuous. The second thing we are asked to do is we are asked to figure out where it's equal to 0. So I'm going to set x squared minus 4x minus 5 equal to 0 and solve for x. Well, if I factor this, I get x minus 5 times x plus 1 is equal to 0. Therefore, x is equal to 5 and x is equal to negative 1. So step 1, get expression on one side, 0 on the other side. Step 2, find your partition numbers. Step 3, you draw a number line, and you place your partition numbers on the number line, negative 1 and 5. It breaks your number line up into different sections, because over here we're going off towards negative infinity, and over here we're going off towards positive infinity. And we need to choose a number in each one of the sections. So between negative infinity and negative 1, if I'm choosing a number between negative infinity and negative 1, I'm going to choose the number negative 2. The number between negative 1 and 5, 0. And a number between 5 and infinity, 6. And it can be any number, it just has to actually exist in that interval. So then, step 4 says, evaluate the expression at each test point and determine whether the inequality statement is true or false. So we're going to use the calculator to figure this out. I'm going to grab our calculator. I'm going to turn it on. And what I need to do again is hit y equals. And here you're going to put in the function. Now recall our function is this x squared minus 4x minus 5. So I'm going to place in here x squared minus 4x minus 5. And I'm going to make sure my table set is still set to ask. So second window for my table set. And thankfully it's still at ask. So then just second in table. All right, the first number I'm plugging in is the number -2. So I plug in -2 and I hit enter, and I get the number 7. I get the answer of 7. So 7 is a positive number, so I know that all the values in this section are positive. Then I'm going to plug in 0, 0 and hit enter, and I end up with -5. So I get -5, which means all the numbers in this section are negative. The last one I'm going to plug in is 6. So again, I hit 6 and then enter, and I get the number of 7. 7's a positive number. That means all the numbers in this section are positive. So if I wanted to figure out where are the values that are greater than or equal to 0, well, the numbers that are greater than or equal to 0 are numbers that are positive, right? Negative numbers are not greater than or equal to 0. Again, 7 is greater than or equal to 0. That is true. 7 is greater than or equal to 0. That is true. -5 is not greater than or equal to 0. That is false. So our answer is going to be anywhere we're true. Well, where does that happen? That happens in this interval and in that interval. Well, what is the answer here? We're going to write it in both interval notation and then set notation. So for our interval notation, we would say -infinity to -1 bracket union 5 to infinity. And we use a bracket because we are equal to. So these numbers would be closed circles. Or we could also write this as my x's need to be less than or equal to -1, or my x's are going to be greater than or equal to 5. Either one of those answers is equivalent. Let's look at the next problem. Number 10. Okay, number 10, same thing. First we want expression on one side, 0 on the other side. So step 1 is done. Step 2 is find those partition numbers. How do you find the partition numbers? They happen where you are discontinuous. Well, this is a rational function. Where is it going to be discontinuous? It's going to be discontinuous any real number where the denominator is equal to 0. So if I set x plus 4 equal to 0 and solve for x, I get x is equal to -4. So -4 is a partition number. And then I also have to set my function, which is 2x plus 3 over x plus 4 equal to 0 and solve for x. Well, this is a rational equation. I can put my 0 over 1 and cross multiply in order to solve this. So I end up with 2x plus 3 is equal to, multiplying the other side, 0. So solving for x on the left, I get 2x is equal to -3, and x is equal to -3 over 2, which is the same as -1.5. So step 3 says draw your number line and place your partition numbers on the number line. -4, -1.5. So now I need to choose some test values, but let's go ahead and put the circles on this one. We did put the circles on the last one. Okay, so again we have the or equal to here. So we know that we have closed circles, except for any number you end up with where you're not defined, any discontinuous number always gets an open circle. Everything else will get a closed circle if you have that or equal to bar. But because -4 is a place where this is discontinuous, it will have an open circle. All right, now let's choose our test values. So a number between -infinity and -4, -5. A number between -4 and -1.5, -2. And a number between -1.5 and infinity, 0. And again, we're going to use a calculator for this. So we put in our function. So we're going to go to y equals, I'll clear this out, and our function was 2x plus 3 over x plus 4. Second and graph for our table. The first thing to plug in is a -5. So -5 and hit enter. And again, we get +7. So this is positive here. What about -2? -2, I hit enter. I get -1/2 or -0.5. So that means all these numbers are negative. Finally, plug in the number 0 and hit enter, and I get 0.75 or 3/4. Well, that is a positive number, so all the numbers here are going to be positive. So again, what makes the inequality statement true? We're trying to figure out where we are smaller than or less than or equal to 0. Less than or equal to 0 means negative numbers. Is this going to be true? No, that's false. We wouldn't shade there. Is this going to be true? Yes, negative 0.5 is smaller than 0. So we are going to shade this area. Is this going to be true? No, 0.75 is not less than or equal to 0. That's false. So then our answer, again in interval notation, would be parentheses, negative 4, comma, negative 3 halves with a bracket, or in set notation we have negative 4 is less than x, which is less than or equal to negative 3 halves. Either one of those answers is correct.